Good morning all, and welcome to the presentation for Agri13007 Assessment 3 Part B, presentation for the Literature Review of Integrated Weed Management. Today's presentation shall be delivered by myself, Kate Ledwig, whom was the writer of the review for the assessment piece of Part A. Before we start today's presentation, just a few interesting facts and definitions to get us in the groove of integrated weed management agricultural practices today. Firstly, I would like to draw your attention to the diagram on the slide. This is a perfect reference as to how integrated weed management should interact with each other. Integrated weed management is the incorporation of several methods, being physical, biological, chemical, and cultural, with the aim of removing or suppressing weeds. A weed is defined as any plant that has established itself in an area where it is not desired. A common example for producers is any plant within a paddock that is not the crop planted, such as saffron thistle within a barley field. Weed management has been an ongoing battle as it costs Australian producers up to $1.5 billion annually, with chemical controls being the majority of controlled methods being utilised. It has been due to the reliance on chemicals such as glyphosate that has resulted in up to 18 countries reporting weed resistance. Keeping on track today, the presentation shall consist of the following shown on the screen: an introduction of the literature review topics, its aim and the significance of the review, the key aspects explored within the paper that included the types of integrated weed management methods and strategies used in agriculture in Australia, the environmental impacts of weeds to the environment, as well as agricultural industry, followed by the future opportunities and direction for integrated weed management for agriculture. The key findings within the review, followed by the solutions for possible issues within the use of integrated weed management programs, and the future research opportunities for the industry. The presentation shall be summed up with a conclusion for the presentation and the findings from the literature review. The project that was undertaken was a review based upon the integrated weed management. The aim of the review was to assess the integrated weed management practices that Australian producers utilised and the effects on the environment from weeds, as well as these methods of weed control. The significance of this project is that the review is Australian focused, where the majority of previous reviews and research projects are international or only review the effectiveness of the practices. A big part of any management system is how well the project is designed and implemented, which is part of many Australian producers fail at due to the number of factors. This has been explored in the review, as well as producers reflect on how they believe integrated weed management is used on farm for a number of agricultural industries in the northwestern region of New South Wales. On the slide, it can also be noted that the research on integrated weed management was not heavily explored until the 1970s following the occurrence of weed resistance, and furthermore, did not become a popular practice with producers until the early 2000s. The key aspects of the review on integrated weed management consisted of an analysis of the practices being used by Australian producers to manage weed problems in Australia. The four categories of weed management, being that of chemical, biological, physical, and cultural, have all been assessed. The second component of the project was assessed on how weeds impacted the environment as well as rural productions. Shown on the slide is a map of Australia that has been shaded to demonstrate the percentages of producers that host on property weed issues, with 85% of Australian producers admitting that they are constantly managing weeds. Of these producers, 90% admit to using herbicide as a control method. Here we have the first of our four integrated weed management system techniques. Starting off, we have our chemical control on the left-hand side of the slide. Chemical controls are the most widely utilised means of weed control and removal by agricultural producers worldwide, and in turn has resulted in high levels of resistance from producers, followed by increasing rates of chemical resistant weeds, also referred to as superweeds. Although the reliance on chemical controls for weeds hosts several negative environmental impacts, it is the most reliable and cheapest option for producers. The process that producers should follow when using chemicals as a weed removal method is identified the weed depending on and how it should be killed, taking into consideration the surrounding flora. In this process, the chemical user label provides appropriate application rates as well as safety equipment required. Depending on the method of application, spraying conditions should be considered as well as should the product's registration requirements as per state. Shifting our focus to the right of the screen, we have the biological component of the integrated weed management plan. Biological controls include bacterial, fungus, and pests for the natural control of weeds. Biological controls aren't commonly used due to the risk factor associated with introducing something new into a new ecosystem where it may thrive better than intended. This can be linked to the cane toad outbreak that began in 1935 with the intention to control the cane beetle, known as the native natural pest. The process required to implement a biological control requires research as to how the control will affect the new environment, followed by the mandatory application to the invasive pests, animals and committee to seek approval prior to a further application to the Australian government and the agency that completes specific testing in order to comply with biosecurity requirements. Although biological controls aren't often used, they can be extremely effective as in many cases they do not affect the environment, require minimal labour requirements, and can reduce the chances of the weed reoccurring due to the new predator being introduced into the environment. For our second component of the integrated weed management types, we have our cultural and physical control methods shown before you. Starting at our cultural techniques for weed management on the left-hand side of the slide, these controls typically manipulate the current farming methods in order to limit the opportunity of the weed's growth. These incorporate techniques that suppress the weed's development whilst promoting the desired crop in many cases. Cultural practices may be completed through the encouragement of practices such as the use of fertilizer to boost the crop's growth in early development, increasing the seeding rate of the intended crop, or even through the changing of smaller row spacings to limit the sunlight exposure to the weeds. Another method used is other species to ward off weeds through the toxins. The second part of our cultural controls is utilising land management to reduce the adaptability of the weed or the vigour of the plant through partaking in techniques such as crop rotations, rotation of chemical types if available, and double cropping. This technique is only plausible if adequate climate and is one of our most important prevention methods is maintaining ground cover, preventing the emergence of weeds between cropping. On our right hand of the slide is our physical methods for weed management. Many of these can be integrated nicely with our cultural controls as both focus on alternative farming methods by the producer. The physical controls for weed management include any physical, such as pulling or hoeing of the weeds, as well as mechanical means in the removal or suppression of the weed. These techniques may include slashing or grazing of the paddock prior to the seed's production or emergence to prevent seeds from being spread, the mulching of the area to reduce sunlight to the plant, thus further growth. As mentioned before, the use of a hoe or shovel may be used in smaller areas where other methods are less desired. This method is not often used due to being very time-consuming and labour-intensive. Utilising machinery for cultivation or tilling the desired paddock before planting disturbs the weed populations. Although cultivation is popular in Australia, this method exposes the soil to erosion and allows for the new weeds population to establish themselves, as well as affecting the soil structure. The final method is that of burning. This technique is effective, but may also host side effects to the soil such as erosion and the destruction of organic matter in the soil. In the use of machinery, it is important to wash down the equipment in an isolated area in order to prevent further weed spreads to the seeds, as this is the most likely means of weeds being spread across Australia. Agricultural productions in Australia covers up to 48% of Australia's total land mass, with 24% of this land being utilised for cropping operations. The challenges that many producers face is the balance between producing a high quality and quantity whilst being environmentally friendly yet sustainable in their operations. The battle against weeds in the agricultural industry is primarily cropping focused in terms of integrated weed management techniques, but it also takes its toll on other agricultural operations. It is from here that we focus on how weeds impact producers when not managed. Weeds, when not controlled properly, host the potential to harm livestock, affecting machinery operations, and can contaminate produce. Contamination of produce includes weeds, seeds getting stuck in the wool, such as burrs, reducing grain quality, both of which lowers the profitability of the product due to the required of cleaning processes. Weeds affect livestock producers through the injury or even death from weed consumption, or even just walking amongst the weed. It has been mentioned that the control of weeds costs producers up to $1.5 billion for weed control, but is almost estimated to cause a further loss of $2.5 billion in production losses. The second component is the effects that weeds have posed on the Australian environment, to which a financial figure cannot be estimated, but it is assumed to be greater than that of agriculture. Weeds affect the natural environment through smothering or blocking the native plants, thus disturbing the natural ecosystem, as weeds are extremely competitive. The major issue is the removal of industrial plants such as the ecosystem, with the potential of removing a food source or natural predator. This then results in further issues where shelter or food source cannot be sourced, disrupting the biodiversity of the environment. In the use of weed management techniques, each holds the potential to harm the environment, and the key is determined which of these is more environmentally sustainable for the rural producers. Environmental impacts for many rural productions can be divided into three areas, being the atmosphere, water, and soil. Shown on the slide is the identified possible effects that weed management alone contribute towards. For the atmosphere, we have global warming and chemical residue. Moving down to our water, the major issue is the leaching of chemicals into waterways that have caused issues for the Great Barrier Reef located off the north coast of Queensland. As for soil, in weed management, it takes the full brunt of the consequences, with the possibility of soil compaction from machinery, the destruction of organic matter through the burning of weeds, soil erosion, and chemical residue being left in the soil. Before determining the future direction for the integrated weed management industry, I conducted a survey with 10 producers all within the Northern Tablelands region of New South Wales. In this survey, I ensured that a variety of producers were introduced to determine where producers believed they sat on the spectrum of integrated weed management. The slide before you is the results from the participating producers within the questionnaire being undertaken in August of 2018. In the survey conducted, all found weeds a major issue for agricultural productions across the variety of the industries. Of the 10 producers, only 40% were participating in what would be considered true integrated weed management, with the integration of 3 or more methods of weed control, while 100% of the group did utilise integrated weed management techniques. For the majority of producers that partook in the survey, only 4 agreed that weed issues had been reduced, while 2 were indecisive as to the season could determine which weeds were the issue for the year. With the results from the survey, it can be said that integrated weed management programs aren't being implemented correctly, whether it be due to lack of education, resources, time, or financial availability, thus the point of the management system being lost and needs to be better developed or introduced to producers. The current direction for integrated weed management is not only to ensure producers are better equipped in the integration of weed management systems, but that of precision agricultural methods. Development of technology followed by the integration into farming has created products that are capable of reducing the cost of integrated weed management methods, environmental impacts, and the effectiveness of techniques used on farm. It is technology such as drones and satellite sensory equipment that has allowed for closer field analysis and mapping, shown on the left-hand image at the bottom being the drone. Smartphone applications and accessible internet allows for faster weed identification, as well as technologies that can spray for singular weeds rather than the whole crop. Technology such as the one shown on the top right of the images is that of a latest technology capable of distinguishing between a crop and the weed within the crop, and has been applied to other popular agricultural technologies such as the drone on the bottom left of the slide. These advances in technology have allowed for the potential to reduce environmental impacts through reduced chemical applications, time, and labour. Future opportunities for the industry would be assess the producers in implementing further technologies into integrated weed management systems in the aim of further reducing the environmental impacts and improving the individual sustainability for agricultural productions. The key findings that stood out throughout the literature review was the substantial environmental effects caused by weeds, the research occurring within the precision agricultural sector, and the high reliance on herbicides for chemical controls by producers. The sheer lack of integrated weed management systems that are implemented by producers, and the effects weeds have on the loss of produce. Much of the studies analysed during the creation of the review, it did reveal that when integrated weed management systems were implemented and completed to the standard of the plan, environmental issues such as ecotoxicity in water and soil was reduced by 89 to 93% in a 12-year study based in France. In this same study, issues such as global warming and ozone formation was reduced by up to 12 to 24%, whilst integrated weed management had no notable change to biodiversity. Other studies highlighted that despite individual weed management techniques having negative effects on the environment, the whole idea of several approaches being utilised minimised the effects to the soil, water, and air, in some cases improved the issues due to these rotations. In another review by S. L. Young, integrated weed management was described as a multi-phased approach that, when implemented correctly, true integrated weed management would occur. As for the issues mentioned earlier, being the lack of integrated weed management systems being implemented correctly, and the reliance on chemicals for weed control, it can be said that there are many viable solutions. With the availability of precision agriculture, chemical applications can be lowered, followed by a reduction in costs and labour by the producer. Educating farmers on the integrated weed management processes in order to correctly plan for success. This then should be assisted through programs and field days to ensure that the integrated weed management systems are implemented correctly in order to achieve the best results. The possibility of adapting farming methods that are less vulnerable to weeds, such as greenhouses and indoor hydroponic systems, is also a great way to expand on the idea. For the future research on the integrated weed management model, the environmental effects and how to better minimise these should be commenced with a focus on real-world producers. In conclusion, weed management is a serious issue for the agricultural industry and can be reduced if integrated weed management systems are utilised more effectively. In terms of reducing the reliance producers have created on chemicals, integrated weed management hosts the potential to assist in this issue through creating alternatives such as methods mentioned throughout the presentation, as well as precision agricultural technologies being developed. In terms of the environment, the use of integrated weed management methods hosts potential harm to the environment, including but not limited to the chemical spraying, burning of the area, as well as the breakdown of soil structure from cultivation that is unnoticed when implemented as a management system, with rotations allowing for the environment to recover. Good land management is a means of protecting against weed outbreaks utilising simple methods such as maintaining a high level of ground cover, washing off machinery before and after use, and monitoring land use. Overall, integrated weed management main objective is the reduction of chemical reliance in the Australian agricultural industry and hosts the potential if implemented correctly. Thank you all for listening. I look forward to your questions. This has been a review on integrated weed management systems in Australia.